Hello everyone. First of all, I thank Dr. Rajagopal for giving this opportunity to talk to all the young minds. And most of this work, what I'm going to present today, has been done in KG Hospital. Hello everybody. Ding dong. Hello everybody. Ding dong. Good afternoon everybody. First of all, I would like to thank Dr. Rajagopal for giving this opportunity to talk to all the young minds sitting here and watching this program. And I also thanked Dr. G. Bhaktochalam, who was given the opportunity to work in his hospital, KG Hospital, and most of this work has been done in KG Hospital. So I'm going to share the experience I had working with Dr. Rajagopal in how we solved some of the problems we faced on a day-to-day basis. So decision support with data science in nephrology. I am Dr. Ilangovan Virappan. So how is data analytics and data science different from the standard medical analysis is most people use something called hypothesis testing, whereas in the presentation what you're going to see now, so we have used something called data science. So what is all this? So in hypothesis testing we do something called null hypothesis. Here we have a prior knowledge about relationship between dependent and independent variable. For example, if we presume that there is no relationship between platelet count and uremic toxin. So this is an example. So we use something like student t-test, sometimes non-parametric test, and then we try to refute this hypothesis. So when we refute this hypothesis, it means there is some relationship. So this is how the standard medical statistics work. But in data analytics, what we do is there is no presumption made. There is no prior knowledge needed to be. So we collect all the data we have. We discover variables which are neglected by most researchers. For example, in one of the studies we did, we found that the platelet count was a significant predictor of paracresol. So we use a completely different analysis. So this is called data analytics. So these are some of the four. I'm giving you four examples. These are all real life examples which we have done it. So some of the complex questions which we cannot do by the normal null hypothesis. So we have done this. The first one is which is the best spot urine test to accurately estimate 24-hour salt intake in healthy individuals and people with kidney disease. We all know salt intake estimation is very important for many diseases. Salt mediated diseases are huge. Hypertension, kidney disease, heart disease. So what the whole world has been doing is a major blunder. That is, they randomly chose a fasting sample, they after meal sample, and so different samples. But what we did different was we designed a method of collecting a baseline sample 1 hour, 2 hours, 4 hours after a meal, and then we found out using. So this is a loading plot what you're seeing, and then what we found out was the first star sodium creatinine ratio has the best prediction. So this way we, even before we started the analysis, we knew which of the 8 different variables we used is going to be the most important in predicting. So this is an example what we have seen. And so what it did is ultimately we made an equation, we named it kg ram vira. So we, as you can see here, you can see next to the red line, you can see the dispersion is very narrow in our prediction equation, and it's quite steep, whereas the most commonly available equations, Kawasaki and Tanaka, did not have this kind of accuracy. So it has a precision and has an accuracy, and with close to zero bias in estimating the correct value. So that is how data analytics helps you to come to a conclusion faster and easier, much more than other studies which have used more samples, longer study duration, more money was spent. So that's the power of data analytics. So next example is predictors of protein bound uremic toxin using commonly available surrogate markers. So protein bound uremic toxins have more damage on the physical and mental function of patients than the other urea and creatinine, the common toxin we all know of. So we wanted to come up with a prediction model which can predict these uremic toxin using common variables, because these toxin to measure directly is cumbersome and costly and not widely available. So this is what we did. So again we did a tree plot, and then we found out that a lot of variables are important, and then finally we narrowed down based on the loading plot that platelet count is very important for paracresol. So this is just an example here. The top one, the green color one, shows that the placebo group, and the more bluish one is the treatment group, and then we were able to show very clearly that platelet count was very useful in predicting paracresol at the end of 90 days. So a simple test which most people have neglected, we managed to use this platelet count along with few other variables in making a model where when otherwise if you have used the null hypothesis testing, we definitely would have missed this. So that's the power of data analytics. So again, this is an interesting study done by one of my colleague Harini along with Dr. Rajagopal. This is detecting urine culture positivity in pregnant women using urinary dipstick alone. So we all know urine culture has to be cultured on a plate, but then here mathematically using a simple dipstick, we found out that some of these variables which commonly people neglected, like specific gravity and pH, were very powerful predictor of positive urine culture. So the variability of prediction in positive urine culture was narrowed down. But 75% was predicted just by urine specific gravity, pus cell, and pH. So this is extremely outstanding, because otherwise we need to wait for a culture for minimum 24 to 48 hours. So this kind of exercise can be a cost saving and also saves a lot of time, and it's impossible with null hypothesis, because we would have never even figured out that these common variables are so powerful in predicting. So again, finally, the last example I'm going to share with you is how mitigation of dialysis induced adverse brain blood flow using data analytics. So what we did was, like, we know that we have been working on cool dialysis and the effect of that on the blood flow in various organ systems, and we worked on the blood flow pattern in cool as well as standard dialysis. And here we found out that which variable to interfere or measure, because we cannot do all the measurement, because all this measurement is very cumbersome, takes more than 30 minutes, and then we cannot use it for patient treatment. So what we found was pulsatility index was uniformly useful in all the vascular territory, left middle cerebral artery, right middle cerebral artery, and basilar artery. So if there is only one parameter that we need to measure, and then we need to follow patients, and that is going to be the pulsatility index. So all these are only possible with data analytics, and with the power of data analytics, we can, even with small sample size, large sample size, and with absolutely no domain knowledge, we can start working. And then of course you need domain knowledge to top on the findings we find, because we need to make sense of what we find. And so that's the power of data analytics in nephrology. So healthcare domain should use data analytic techniques more often to identify new independent variable for prediction. Better prediction comes with better accuracy and better precision, and leads to better decision. Thank you all. Thank you for the opportunity. And I also thank Dr. GB, Chairman KG Hospital, Dr. Rajagopal, former head ISI Coimbatore, my colleague Dr. Ramasamy, and the DNB fellows who worked with us for many of these projects. Thank you. Have a great day.